All right, hey. So I spend a lot of my days jumping into large code bases that I've never seen before, and I always am wanting to apply code to it, which in Go is pretty hard compared to languages like Java and Ruby, for instance. And same thing with using third-party packages, that sometimes I want to just apply behavior to third-party packages, but I don't really want to take the time to do so. This is what I think really kind of sucks about Go. And when I mention packaging, people bring up versioning and dependencies, but that's not really my complaint with the packaging. It's the fact that I can't do this easily. So I was talking to this guy in London a few weeks ago, and he was like, oh, do you know about Aspect J? And there might be some neckbeards in the crowd with grayer whiskers than mine, and they might be plotting to kill me when I mention this. But in actuality, aspect-oriented programming actually has some good fits to Go. And I am not a code purist at all. I'm very much a pragmatist. I code to get shit done. Rob Pike has this wonderful quote from GopherFest, which is our full-time job, write a program to write a program. Enter code weaving. Like I said, Go is actually a decent fit. And we already have existing tools that do great jobs at similar things. Go Thump, Go Fix, Go Generate. Go Thump is awesome when you're trying to move stuff around from the APIs. But here's an example from Go Fix. And there's a lot of stuff going on, and it's like a one-time operation. Well, sometimes I want to apply the code and then rip it back out. And I don't want that code in my repository. I don't want to leave artifacts, because chances are I'm operating on somebody else's code. So to go over some quick definitions, if you've never heard of this before, an aspect is basically just behavior that you want to apply to a given code base that's not there. Logging is the most canonical example. It really has absolutely nothing at all to do with your business logic. Some ways of applying the code is, if you call a method, you can place that code before you call the method or after you call the method, or you can execute. So this is placing code before the method is executed or after it is. And then within, it's like if you have all these different methods within a function that you want to apply behavior to. So latency timing, for instance. Advice is simply just code that you want to apply. So why would you want to do this? Well, we already addressed logging, but there's monitoring, there's performance analysis, debugging and tracing, undo functionality, validation, behavior mutation, security reasons, and transactions. So let's look at some examples of what this tool does. And this is still being hacked out, so don't mind the half JSON, half Go. But here, what we're doing is every time we call string conv i2a, we're going to go ahead and log the fact that this is occurring. Here we have code validation. Before we execute the blah method that has the stuff string, we're going to go ahead and see if stuff equals stuff, and if not, we're going to return false. And we can apply this to every single time we call blah, and it'll generate in your binary. Here's another more complicated one. We want to time database query latencies. So before we call query row, if you're talking to the Postgres or whatever, we're going to start our timer. And then after query row has been done executing, we're going to end it, and we're going to log out the latency that was required. Here's another thing that we use at our own company. Every time you get a panic within a Go routine, you know, those are kind of hard to catch. And so we'll go ahead and rewrite the Go behavior. Every time you kick off a Go routine, it'll rewrite it, and it'll go ahead and log that panic. Lastly, we went ahead and opened up a repository with samples, because I think the behavior that we want to apply, we want to share it with people, and you don't want to have to rewrite the whole thing every time. That's actually like one core reason why we did this, was because we don't want to hack it in, hack it out. You're going to miss it. It's just really frustrating and so forth. More eyes, better software. You don't have to reinvent the wheel. So some caveats. I've only spent like 2 nights on this because I was just kind of scratching a niche I had. So right now it's really slow. There's a lot of file I/O that's needless, and we can refactor that out. And it's hacky as all hell. So if you're looking for open source stuff to jump into, we can definitely use any contributions you have. These are the 2 repositories. Go Weave and is the main compilation tool, and then the Loom is where we're putting samples and also examples. And that's it. Yes.
Questions for Ian?
I do.
Janie does.
So is this pre-processing?
I'm sorry?
How's it actually applied to our Go code?
How does it apply it?
Yeah, is it pre-processing?
So it's a compile time tool. You have a weave file, which I showed in there, and so you can apply any weave file that you have in your directory to the entire project that you have. So wherever the point cut is basically, you can think of it as a regex for code places, to where you can apply that behavior. It'll apply it to all those places in your code. And so, and then you use the go weave command to kind of weave it into your binary.
Cool. Thank you.
Okay, that's all the time we have. Thank you. My mic on? There we go. Thank you very much, Ian.